Good morning. In this video, we are going to discuss about three important topics. First one is mass moment of inertia. Second one is radius of gyration. And third one is the formula for various objects. First, let us go to mass moment of inertia. Moment of inertia means there are two types. First one is area moment of inertia, and the second one is mass moment of inertia. And so far we have discussed about area moment of inertia only almost 5 to 6 videos. We discussed about area moment of inertia only, where the area, that is cross sectional area, plays an important role. Now we are going to discuss about mass moment of inertia, where the mass is going to play a very important role. Now let us go to the video. Already I discussed about this in my previous videos, one of my previous videos. So I will go in fast. There are two classifications in mass moment of inertia. One is for discrete system, and the corresponding formula is the summation of I1 to n mi into Ri the whole square. And the second system is continuous system. Continuous system, and here is the formula, the integration of r square into dm. Okay, here the number of elements are infinite, and for the first case the number of elements are finite. Now this is the general formula for mass moment of inertia, I equal to mass into r square, where r is nothing but the perpendicular distance. So from this equation we can say that the mass moment of inertia depends upon mass as well as r. Here is r is nothing but the distribution. Okay, here r is related to the distribution of this mass. So normally the mass moment of inertia not only depends upon mass but also the distribution of that mass. Let me consider two cases now. I am going to consider two disks of same mass. Now in the first case, the maximum masses are distributed around the center. So this is the axis and this is the cross section of the disk. Now you see here the maximum masses are around the center. Now this is the position of the center of mass and this is the axis. Now the perpendicular distance can be taken as r1. You see here maximum masses are distributed around the center. Now this is second case which has the same mass but the maximum masses are distributed away from the axis or at the outer periphery. Here the maximum masses are located. Now the centroid will be shifted. Now this is the point of centroid, this is the axis of rotation. Now this is the distance r2. Okay, so now I am going to apply this formula into both the cases. Now in both the cases the mass remains constant, whereas the r is different. That means the r2 is greater than r1. So the moment of inertia offered by the second object is greater than the first one. Okay, why? Because the same mass but distribution of mass that play important role in mass moment of inertia. Okay, and moreover that leads to another concept called radius of gyration. So here is the new topic, the second one, radius of gyration. Now let me go to the definition. Radius of gyration is the imaginary distance from the axis at which the total mass of the body is assumed concentrated and at which the moment of inertia will also be equal to the actual moment of inertia. Now consider a mass m. This is the center of that mass which is being located at a distance of r from the axis AA. Now the mass moment of inertia for this condition is, here's a formula, I equal to mr square. Now the same mass is being located at this point, okay, so as that the moment of inertia is equal to the actual one. Okay. The mass is moved and located at this point, the moment of inertia should be same. Okay. Now this distance is nothing but radius of gyration. It enables us to locate the mass at some place or at our desired place, but the mass moment of inertia in both the cases would be equal and same. In that condition, this distance is now it is called as radius of gyration. The corresponding formula is I equal to mk square, where m is nothing but mass and k is the radius of gyration, or it is called as equivalent distance, okay, which enables us to locate this mass to the desired place. Now, from this formula, the radius of gyration can be arranged as square root of I by m, and it has the unit of mm. And for area moment of inertia, in the place of m, here you have to substitute a. Now consider an area A having the dimensions b and d. Now the moment of inertia with respect to this OX axis is b d cube by 3. Now let me take this as equation number 2. Now the same area is assumed to be concentrated at this point. Now in both the cases you will have the same area moment of inertia. Now this distance can be called as radius of gyration. Now let us see the distance. This is the second equation, which is nothing but the moment of inertia of this area with respect to this axis. Now for this case, the moment of inertia is a into k square, which is nothing but from this one, I equal to mk square. Now in the place of m, area is substituted. So this is equation number 3. Now you see here that these two cases, the moment of inertia are equal. So equation number 3 can be equal to equation number 2. Very important thing to note. Okay. Now substitute both the equations. Finally, you will get the answer as k equal to d by root 3, where d is nothing but the height of this rectangle. Okay. So I can able to locate this area at a distance of d by root 3, so as the moment of inertia will be same, will be equal in both the cases. So in this way, the radius of gyration will help us to locate the mass or area. Now the third important discussion for today's video is the mass moment of inertia of common shapes. The first shape is a thin disk. So here is the thin disk where the thickness is assumed to be negligible. So mass, and this is the point centroid or center of gravity, and the radius of the disk. Now the corresponding formula, okay, with respect to this axis is 1 by 2 m into r square. Now the second object is a thin ring. Okay, this is thin ring, thickness is assumed to be very small, and this is the centroidal axis, and about which the mass moment of inertia is Ig equal to m r square. Now the third object is a sphere. This is the sphere, this is the center of gravity G, and about which the mass moment of inertia is 2 by 5 m r square. The next one is a cylinder rod of length L and mass m. This is the position of center of gravity, this is the axis, and the mass moment of inertia with respect to this axis is 1 by 12 m into L square. Now the last one is the rectangular plate. Here is the width is equal to b and height is equal to m. This is the center of gravity, and now the moment of inertia with respect to through this axis, which is equal to 1 by 12 m in square bracket a square plus b square. So in this video we discussed three important things. First thing is the mass moment of inertia and its definition and its types classification. Then next one is the radius of gyration, the purpose of radius of gyration and its definition formula. Then we discuss the mass moment of inertia of common shapes. Thank you. We will meet in the next video where we will solve a problem in mass moment of inertia. Thank you.